The Square D Earli-gard smoke detectors are 4-wire devices requiring 120 volts, neutral, interconnect, and ground connections manufactured in the early 1980s. They are wired with a 2-wire NM cable instead of the required 3-wire configuration. It is not recommended to use 3-wire detectors in this setup because the ground wire will not be connected. Rewiring with 3-wire NM cable is the most compliant and recommended solution, as this will provide a proper ground connection for the detectors. Another option is to install 4-wire detectors that are compatible with the existing wiring, because these detectors typically do not require a ground connection. An electrician can add separate grounding wires to the existing NM cable, however, this option may be more labor-intensive and costly. It is crucial to follow local electrical codes and consult with a qualified electrician for proper installation and wiring. Smoke detectors should be replaced every 10 years to ensure optimal performance, and test smoke detectors regularly to ensure they are functioning properly. If possible, obtain more information about the specific model and series of the Earli-gard detectors for further guidance. Ensuring proper wiring and functionality of smoke detectors is essential for safety. The absence of a ground wire in a 2-wire system can lead to potential hazards and non-compliance with electrical codes. The National Electrical Code, or NEC, provides guidelines for safe wiring practices, and it's important to adhere to these standards. When dealing with electrical systems, it's always best to err on the side of caution and seek professional assistance. An electrician can assess the situation, provide expert advice, and perform the necessary work to ensure that the smoke detectors are installed correctly and safely. When considering rewiring options, it's important to understand the different types of NM cables available. The 3-wire NM cable includes a ground wire, which is essential for proper grounding of electrical devices. This ground wire provides a path for fault current to flow back to the source, tripping the circuit breaker and preventing electrical shock. In contrast, a 2-wire NM cable does not include a ground wire, making it unsuitable for use with devices that require grounding. When installing 4-wire detectors, it's important to ensure that they are compatible with the existing wiring system. Some 4-wire detectors are designed to operate without a ground connection, while others require a ground connection for proper operation. Consult the manufacturer's specifications to determine the appropriate wiring configuration. Adding separate grounding wires to the existing NM cable can be a viable option, but it requires careful planning and execution. The grounding wires must be properly sized and connected to a grounding electrode system to ensure effective grounding. An electrician can determine the appropriate size of the grounding wires and ensure that they are properly connected. In addition to the wiring considerations, it's also important to ensure that the smoke detectors are installed in the correct locations. The National Fire Protection Association, or NFPA, provides guidelines for smoke detector placement, and it's important to follow these guidelines to maximize the effectiveness of the detectors. Smoke detectors should be installed on every level of the home, including the basement and attic, and inside and outside of each sleeping area. They should also be installed at least 10 feet from cooking appliances to prevent false alarms. Regular testing and maintenance of smoke detectors are essential for ensuring their proper operation. Smoke detectors should be tested monthly by pressing the test button and listening for the alarm. They should also be cleaned regularly to remove dust and debris that can interfere with their operation. The batteries in smoke detectors should be replaced at least once a year, or more frequently if the detector chirps to indicate low battery. When replacing old smoke detectors, it's important to dispose of them properly. Some smoke detectors contain radioactive materials such as americium-241, which can be harmful to the environment if not disposed of properly. Check with your local waste management agency for information on how to properly dispose of old smoke detectors. In addition to the above considerations, it's also important to be aware of any local electrical codes or regulations that may apply to the installation of smoke detectors. These codes may specify requirements for wiring, placement, and maintenance of smoke detectors. Consult with your local building department or electrical inspector for more information. The information provided here is for general guidance only and should not be considered a substitute for professional advice. Always consult with a qualified electrician for any electrical work to ensure safety and compliance with applicable codes and regulations. Furthermore, when working with electrical systems, it is essential to take appropriate safety precautions. Always turn off the power to the circuit before working on any electrical components. Use insulated tools and wear appropriate personal protective equipment, such as safety glasses and gloves. If you are not comfortable working with electrical systems, it is best to leave the work to a qualified electrician. Electrical work can be dangerous, and it's important to take the necessary precautions to protect yourself and others from harm. Here is an expansion on the grounding issue. Grounding is a critical safety feature in electrical systems. It provides a low resistance path for fault current to flow back to the source, tripping the circuit breaker and preventing electrical shock. Without a proper ground connection, fault current can flow through unintended paths such as a person's body, causing serious injury or death. In the case of the Square D Earli-gard smoke detectors, the ground wire is intended to provide a safe path for fault current in the event of a short circuit or other electrical fault. By connecting the ground wire to a grounding electrode system, such as a ground rod or water pipe, the fault current is safely diverted away from people and equipment. The absence of a ground wire in a two-wire system means that there is no dedicated path for fault current to flow. In this situation, fault current can flow through other conductive paths, such as metal conduit or built-in components, creating a potential shock hazard. This is why it is not recommended to use three-wire detectors in a two-wire system, as the ground wire would not be properly connected. When rewiring with three-wire NM cable, it is important to ensure that the ground wire is properly connected to a grounding electrode system. This can be done by connecting the ground wire to a ground rod or water pipe, or by connecting it to a grounding busbar in the electrical panel. The grounding electrode system must be properly installed and maintained to ensure effective grounding. In addition to providing a path for fault current, grounding also helps to reduce electrical noise and interference. Electrical noise can interfere with the operation of sensitive electronic equipment, such as smoke detectors. By providing a low impedance path to ground, grounding helps to filter out electrical noise and improve the performance of electronic devices. When adding separate grounding wires to the existing NM cable, it is important to ensure that the grounding wires are properly sized. The size of the grounding wires must be adequate to carry the maximum fault current that could occur in the circuit. The National Electrical Code, or NEC, provides guidelines for sizing grounding wires based on the size of the circuit conductors. It is also important to ensure that the grounding wires are properly connected to a grounding electrode system. The grounding wires must be connected to a ground rod or water pipe, or to a grounding busbar in the electrical panel. The grounding electrode system must be properly installed and maintained to ensure effective grounding. The grounding electrode conductor, which connects the grounding busbar to the grounding electrode, must also be properly sized. The size of the grounding electrode conductor must be adequate to carry the maximum fault current that could occur in the system. The NEC provides guidelines for sizing grounding electrode conductors based on the size of the service entrance conductors. When installing or modifying electrical systems, it is always best to consult with a qualified electrician. An electrician can assess the situation, provide expert advice, and perform the necessary work to ensure that the electrical system is installed correctly and safely. Furthermore, they can also ensure the ground connection is effective. In the context of smoke detectors, having a properly grounded system can also help protect the devices from power surges and other electrical disturbances. Power surges can damage electronic components and reduce the lifespan of smoke detectors. A properly grounded system can help to divert power surges away from the smoke detectors, protecting them from damage. In addition to the safety benefits of grounding, there are also performance benefits. A properly grounded system can help to reduce electrical noise and interference, which can improve the accuracy and reliability of smoke detectors. Electrical noise can cause false alarms or prevent the detectors from detecting smoke properly. By reducing electrical noise, grounding can help to ensure that the smoke detectors are functioning properly and providing accurate warnings. It is also important to consider the type of grounding electrode system used. There are several types of grounding electrode systems, including ground rods, water pipes, and concrete-encased electrodes. Each type of grounding electrode system has its own advantages and disadvantages. Ground rods are relatively easy to install and are suitable for most residential applications. However, they may not be as effective in areas with poor soil conductivity. Water pipes can provide a good grounding electrode if they are made of metal and are in direct contact with the earth. However, plastic water pipes are not suitable for use as grounding electrodes. Concrete-encased electrodes are the most effective type of grounding electrode system. They consist of a bare copper conductor encased in concrete. Concrete-encased electrodes provide a large surface area for contact with the earth, resulting in a low-resistance ground connection. The choice of grounding electrode system will depend on the specific site conditions and local electrical codes. An electrician can assess the situation and recommend the most appropriate type of grounding electrode system for your application. Finally, it is important to remember that grounding is just one aspect of electrical safety. There are many other factors that contribute to electrical safety, such as proper wiring practices, overcurrent protection, and insulation. By following all applicable electrical codes and regulations, and by taking appropriate safety precautions, you can help to ensure a safe electrical system for your home or business. The Square D Earli-gard smoke detectors, being older models, might also have specific grounding requirements or recommendations that are not immediately obvious. It's advisable to consult any available documentation or seek advice from an expert familiar with these older models. They may have insights into specific grounding techniques or considerations that are relevant to these particular detectors. Moreover, older electrical systems might not always conform to modern safety standards. It's possible that the original wiring installation was not performed in accordance with current best practices, which could further complicate the grounding situation. A thorough inspection of the entire electrical system by a qualified electrician is recommended to identify any potential safety issues and ensure that the system meets current codes and standards.